Okay, this question is asking us to find the force F about the moment of the force actually about point A. So this is what we need to do. We were given some values, alpha and gamma. So let's put that down. Alpha equals to 45 degrees. Gamma equals to 45 degrees as well. But we weren't given the value for beta. So we need to solve for beta. Cosine square alpha, that looks like gamma. Alpha, alpha, okay, square plus cosine beta square plus cosine gamma square equals to 1. Using this relationship, we can solve for beta. We do that simply by plugging in the values for alpha and gamma. 45 plus cosine square beta plus cosine square 45 equals to 1. So solving for beta, we have b cosine square equals 1, 1 minus 2 cosine square 45, because cosine square plus cosine square is 2 of them. Then subtracting that from both sides, we have this. So in order to find cosine beta, we find the square root of both sides. Like that. And then to solve for beta, we simply find the cosine inverse of whatever this is. Where's my calculator? Let's plug that in. 1 minus 2 cosine square of 45 degrees. Okay, that results to 0. So b equals cosine inverse of 0. And what is the cosine inverse of 0? That is 90 degrees. So now we know beta equals to 90 degrees. Now we need to find the components of the force F. Well, we're given the force F was 300 pounds. So now we need to find the x component, y component, and the z component as well. And we simply do that by multiplying by cosine alpha, cosine beta, and cosine gamma without the squares. So your force is equal to F times cosine alpha. To get that right, yes. Cosine alpha, I in the I direction, plus cosine beta, J, plus cosine gamma in the K direction. So well, we now have the value for beta, which is 90 degrees. So we can go ahead and plug all these values into the F right here. So this is F cosine of 45i plus cosine of 90j plus cosine of 45k. Well, we know that F is 300, so why not we do this? Just erase this right here and put in 300 for our value, since we know what that is. And that's 300 pounds. Squeeze it right there. So multiplying this out, we get 212i. And this is just a 0, 0j, and also 212 in the k direction. So we got the force. Now we need to find the moment. Well, for a three-dimensional problem, the moment is equals to the unit vector dot r cross f. This is the unit vector here. Unit vector. Okay, what is wrong with this unit to vector? And then we have the position vector. Position vector Okay, there's really something wrong with this pen right now. Uh, and then we have the force. Well, this can also be written as a matrix where we have U. Well, U is just IJK. Your R is your RX, RY, and RZ. And your force is Fx, Fy, and Fz. So let me just copy this over here again and take this part off because the IJK remains the same. Now we need to find out what the values of Rx, Ry, and Rz are. So going back here, we can write this as 0, 0, 0 for the O. And then for A, this is going in the X direction by 2 feet, so this is 2. Well, there's no Y change here, so this is 0. And it's not going up or down, so this is also 0 as well. And you want your vector, your position vector, to be going towards the point. So in order to find this, well, this is R over A. So R over A simply means the position at O minus the position at A. So that's 0, 0, 0, since we have that here, minus 2, 0, 0, 2, 0, 0. Well, here 0 minus 2 is negative 2, and we have 0 and 0 for the remaining 2. So this is our Rx, Ry, and our Rz. So scrolling down, we just have minus 2, 0, and 0. Well, here we already have the the force and its components. So this is basically just 212. Let's go down a bit. 0 and 212 here. Well, now we need to compute the determinant of this right here. There are, well, many ways you can do that. I'll just go with the basic cofactor expansion method. So we start with the I, and we have two submatrices. So basically cross this out, what you're left over here, which is 0, 0, 212, 212. And then the next one is a J, and that's going to be negative. The first is positive, negative, positive, or positive, negative, positive if you're using the first column. So it's like a checkerboard kind of thing. So here for the J, if we cross out the row and column in the J, we have negative 2 left, 0, 2, 1, 2, and 2, 1. Okay, this should be a 0. This is a mistake. This is a 0 here. So this is a 0. So this is negative 2, 212, 0, and 212. So we also apply the same thing here. We don't need this, we don't need this. Positive k is minus 2, 0, 2, 1, 2, and 0. So over here, multiplying 0 by 212 is 0 minus this, so we have 0i minus j. So minus 2 times 212 is negative 414, and this is 0 plus k at 0 minus 0. So all we're left with is positive 414. This is a 2. 2 times 2 is 2. Yes. So this is a 2 here. So this should actually be 424 in the J direction because negative and negative cancel out. And this is going to be in feet pound. Those are units were in feet and pounds. So that is the moment of the force about the point A. 424 in the J direction, feet pound to find an answer.